Hey Kata, would you like to write a 3D model?
Wait, do you have a friend that is called 3D Model?
No? What?
Aren't we writing to someone?
No. We are going to write a 3D object in JavaScript
Why?
because I love pain.
This is weird. I, I mean, weird. Okay.
Let's start from the beginning.
Seriously, we worked together for some years in a cat company. Why don't you simply model it in the classic way? Explain to the people that is following us.
Well, because I love pain. No, seriously.
Okay, okay.
So, history, long story short, uh, I wanted to have a purely web-based flow for these models, but in reality, I like the idea of storing this model as these models as code because it makes them readable, it makes them versionable, it makes them easy to parameterize. I love open source.
Yeah, and all that complexity makes complexity also to explain that concept. Probably
Yes.
you love pain, but I like the versionable part. It's one of my favorite, probably, of that solution.
Yeah. So here it is. This is it's
Wow.
technically a website. It's called OpenJS CAD. And you can
So you doesn't
go on.
install anything.
No, you don't necessarily just go on a website. I mean, if you want, you can run it on your machine. There are some community ports that make it more of an application. But
Hmm.
you don't even need to render it because you can. This is built as a set of libraries, so you can potentially
Yeah.
just go do your model manipulation and do some analysis on the output object because maybe you want to run some tests because you're building some libraries, or you just analyzing some model and you want to get some metadata out of it.
Yeah.
You don't even need to run it in a browser. You can do it whatever you want.
Nice. Nice.
And
But if you have a virtual machine, remember to mock the hardware acceleration.
yeah, sorry
Uh,
folks, this experience may look a bit choppy on this virtual machine because we don't have acceleration. But on a real machine with a real GPU, it's really smooth. It's a really cool piece of software.
yeah.
So let's look at this initial example. So it's just a show off of the basic elements that they have. So just go, you load your library, you have your basic shape, cube, cuboid, cylinder, cylinder elliptical, ellipsoid, and so on
Yeah.
and so forth. I mean, there are many others.
Not bad.
So it's going here, it's building a bunch of them, it's doing some magic voodoo to align them on a grid, and then it's just exporting this function, this main function, as the entry point, and so it just goes there. So if you want to, let's say that we want to keep the cube, you want to keep the sphere, we want to keep the cylinder, and the two choruses. Just re-render, and there they are. So there
Yeah.
it goes.
A nice set of primitives.
Yeah, and as if you are like me and you don't remember everything just right away, or if you need to learn, you can just go. They have some really nice documentation. So if you want to see what a cube is, it's in the primitives
Yeah.
and it's there. I mean, it has to have a center and a size. Or if you want to have a sphere, it's here. It has to have a center, radius, some
Okay.
segments, and the axis is built a bit around.
Nice.
And you can go and search for all the APIs that you need to do to build your model.
So you
So
have a really small learning curve.
yeah, it's a it's a bit steep at the beginning, but after a while you remember the majority, or you just keep your documentation open. I mean, I do that even normally, so it's better to just keep an eye out for that. And then
I'm trying to sugarcoat the pill.
Yeah. So let's turn off the grid for a moment, and there are 2D shapes, 2D primitives, and this may look weird, but it will make more sense later. And let's look at spheres, for example. Different type of spheres. And an interesting thing that comes from spheres is that you will notice that there is these segments. And one of the things that I like is to just either expose it as an argument or something there, have these segments configuration, because by default you can go and say, oh, I have my segments are this, and you just have your shapes capturing it. And let's say that we want to keep this one, we don't care about this one, we don't care about these two, and we capture these, so we re-render. And if you take a look, these are a bit, I mean, they're tessellated, but I mean, they are great. They're rendered really, really fast. If you're doing some experimental things, is great. And then you go and you say, oh, now I want it smooth, 64. Or now I want it really smooth, 128. And you just go and you get your super smooth model you can send for printing. Nice. And then it will say, okay, but now let's do some development. So maybe 32. And you go back to something manageable while you are designing. So this is really cool. And
especially without auto acceleration.
Yeah, especially without auto acceleration. So rounded cuboid. And well, so this is a thing that happens every once in a while. Some models do this, so you can just rerun it and
load.
It will, and it just goes. This is really cool because
nice soap.
Yeah, it's a piece of soap. In this case, it's cool because you can actually have params, and you can expose a bunch of params to the outside world, and so this will show up here. And so you can go and say, oh, actually, I want it a bit bigger, 20, and I want it a bit smaller, so 5, and I want it not rounded.
Oh, no, you break my soap.
Yeah, and you can just go and add a lot of configurations in here and just make it yours.
Really nice.
Yeah.
So I can add the text to my soap.
Yeah, we can add text. You can just go and render some text. And if you want, you can use what's called Boolean operations, and you can go and carve it or add it or do stuff to your basic block. So, I mean, this is classical.
Okay, I got it.
Yeah, means classical Boolean operations.
I can have my custom soap.
Yeah, go and print your plastic soap.
I cannot use it probably, but if you have enough follower, probably we can try to print with soap. No, I'm joking.
No, please don't. Let's not do it. So you have your basic operations, unions, subtraction, intersection. You can go and do. I mean, it's classical geometric Boolean operations. You can do stuff, you can carve it, you can subtract it, and I'll do a lot of things there. And,
like you're modeling in the classic way, but versionable.
And then you can go, I mean, and repeatable, because I mean, you did a bunch of things, so you want to change it, and you just rerun all your pipeline. You don't need to go back and remember what you did. It's everything printed. And
also parameterized.
And so you have some operators, which is, in this case, is center, that you can use, and you can use it, for example, to take your shape and center it around some axis. And this is useful if you're trying to change the place where you're gripping when you're doing some transformations. And you can do some nice stuff, like, for example, measuring a bounding box. And in this case, you're going here, and we are rotating. You're rotating this thing.
Put it in a cage.
And you're just computing the bounding box of it's a trap. It's computing the bounding box of your object, and you can do nice things like going and giving colors and this kind of stuff.
Okay.
And
But one question about that. That colors have any sense in 3D printing? No, probably only if you are trying to make a model for something else.
yeah, I mean, this information depends on the output format. Some export formats actually support colors, other don't. But even if you're
Okay.
going for 3D printing where you don't care, it's really nice because maybe you're doing, I don't know, you're doing a cup for a bottle, or you're doing a box for an object. And so if you
Yeah.
have the model of the object, you can render it with a different color, so you can see how the two interact together, and then you just drop the one that you don't care, and you keep the one you want to print.
Nice.
And
Also see the transparency, then it's nice.
yeah, you can use transparency and do some nice things. Maybe while you're designing something that has a cavity, you make it transparent to see the cavity, and yeah, and do really nice things with it. And I mean, these are
Nice
simple
debug
shapes.
feature also, I think.
Yeah. And I mean, we're doing some really simple stuff right now. And if you want to do something more advanced, you can go and do, for example, holes. And the idea is that you have a bunch of shapes, and then you can go and say, either give me a shape that covers all of them, the minimum shape that covers all of them. So you see that here is going and connecting stuff together, whole chain, which is connect the first two together, then the second and the third, and the third and the fourth, and just put everything together. And so you can go and do things like this. And if you want to go further with more advanced shapes, you can start playing with extrusions, and here's where 2D shapes comes into play, is that you can go and take some shapes and extrude them, either 2D or 3D. You can say, oh, I want to smear it. You want to extrude it along a path, along a line, and you can go in and again look at the documentation. You can do it on a rectangle or a linear over a polygon, or you can do a lot of things here. And you can do some manipulation. You can twist it while you're doing it, and you can rotate it, and you can do a lot of interesting things here. If you need to go even further, you can use Bezier curves. And I mean, remember, these things were made for designers and by designers, so they allow you to do these super smooth lines, and you can use these lines to as a basis for basic shapes or for extrusions. So you can go and do these super nice things, and you can just go in and see you have your control points. I mean, it gets complicated after a while, but it's nice. It's code. You can just build libraries and hide all the complexity behind. And you can do even more advanced extrusions, where you go and you are actually controlling slices. So you're saying, oh, I want this shape to be made of 32 slices or 16 slices, and it just gives you a callback and says, okay, give me the slice at percentage 25, percentage at 32. You just have your progression through the shape, and you can go and build different pieces, and it's going to connect them together and doing some operations. And you can go
really nice.
And when you put all of this together, you can go and build something like this. Nuts and bolts.
Through me.
Yeah, you can go, you can export it, you can print it, you can add it to your game, you can send it to someone that uses classical CAD software to do some other operations there, and you can do nice things.
So we doesn't writing with an attachment to someone, a physical attachment.
Yeah, potentially.
So we can send that to your friend with the model.
No, but well,
okay. But what if I have an STL?
Well, I mean, if you already have,
I can load it.
Yeah, if you already have a model, you can do something interesting, which is if you make a folder and you have your STL, existing STL, and you just build your own index.js. We're doing stuff here. We're loading it. We're giving it a different color. Let's just change the color, a bit of transparency. And you just go here.
You're transparent. You like the transparency.
And you can go and just take the folder, you drop it, and it goes. So you can have really complex projects with multiple files in it, with libraries and a lot of stuff, just drag and drop. It's going to run and load all that code. So this is from a previous project I did. And we can go into details on what it is another time. So
drop it like thought.
Yeah. And so in future episodes, we could actually go and design something and build some models from scratch.
Oh, yeah. Like, share, and subscribe, and leave a comment if you would like us to model something specific. Yeah, why not?
Yeah. See you next time, folks.